Hey guys, welcome to AlgoYogi and let's solve symmetric tree today. So the problem says, given the root of a binary tree, check whether it is a mirror of itself. What does that mean? Let's change the view here. So this particular example is symmetric. This tree is symmetric. And the reason is, so the root itself is symmetric because you don't have to basically have another root to compare it. You're comparing it itself, so it's symmetric to itself. So, but you compare the values of its left and right subtrees, which is equal here, but you also check if their left and right subtrees are symmetric to left and right subtree of this. So basically you're checking for this left and this right of our root, and to check that you're going to check the values first, and then you're going to compare the left of your left subtree to the right of your right subtree, and then so you will be comparing these two, and then you will be comparing these two, which is true in this case. So in our solution we'll be simply calling a symmetric function on left and right, and we don't have to do it for the root because it is symmetric to itself. So basically we're checking if left subtree is symmetric to right subtree, and that will be basically checking the values. They could be none, they could not be none. If they're both none, then it's true. If one is none, then it's false. But then we have to call the function recursively on the left of this one to the right of this, so left and right. So we'll be calling the function is recursive, like the recursive function is symmetric on the left subtree of our left to on the right subtree of our right, and right subtree of our left to the left subtree of right. Getting kind of confusing, but let's just switch it to our code editor, because I think we have done enough problem. And as I said, like it's very similar to a same tree, and I'll show you how. I'm trying to change the view here. Okay, so what we are really doing, let's define a recursive function called check symmetric. And we are going to give it left and right. So root is symmetric itself, so we're not going to check it on root. So the reason I'm saying it here is we will be calling this function return this function, inner function, as part of our main function, and that will be just calling it on root.left and root.right, because root is symmetric. I don't know why I'm saying it again and again, but this makes sense, right? Like we're not checking for the root because root is symmetric. Like put the root on the root. You don't have to like flip left to right or right to left. Okay, so if left is none and right is none, that means they are symmetric. So we return true. Okay, awesome. But if any of them is not none, then we return false. Sorry, not none, true. Then we return false. And let's change it to or. Okay, and now what? Now these are the base condition, they're done. What we talked about is we're going to check the left of our left subtree to the right of our right subtree, and the right of our left subtree to the left of our right subtree. It's very clear in my head. Okay, I hope it's not confusing to you guys, so let's write it down. We're really simply returning is if the values, first check the values, left dot well is equal to right dot well, and check left side to the right side. That's what we want to compare. So, and then let's call it on the other side as well, which is right of the left and left of the right. Awesome. Okay. Now what? We simply just run the... I hope it's not confusing, right? Like we're just checking the values of these two, left and right, and then we're calling the function on the left to the left of right. So left of the left and right of the right, and right of the left, which is 4 here, and the left of the right. So this is the left of this right. Okay, and let's run it. Okay, let's try to submit it. Awesome. Time complexity, let's write it down. I mean, they're all same in pretty much all the trees question, which is big of n, because if for that many nodes we are basically iterating, we're calling it on all the nodes except root, and it's just one root, so you know, n-1, we're not going to write n-1. Is space complexity would be, that would be big of n or h as well. H is height, which could be equal to n. So okay, let's go back to our AlgoYogi and mark this problem solved. So we're done with all the easy problems now, and we will be moving to the medium problems. And let's keep going, guys. So please make use of AlgoYogi and show your support on YouTube. Bye bye.